Hey students! Welcome back to the channel where maths makes sense, and maybe even makes you laugh a little. Today, we're diving into a topic that follows you from grade 11, right through grade 12. Let's start with the basics, the exponent rules. These are the 6 golden rules you must know. The product rule, a to the power of m, multiplied by a to the power of n, is equal to a to the power of m plus n. When you multiply two powers with the same bases, add their exponents. Next is the quotient rule. A to the power of m over a to the power of n is equal to a to the power of m minus n. When you divide two powers with the same bases, subtract their exponents. Now the third rule is the power to an exponent rule. To raise a power to an exponent, you need to multiply the exponents together. The next rule is the zero exponent rule. A to the power of 0 is equal to 1. Any base with the power 0 is always 1. Next rule is the negative exponent rule. A to the power of negative n is equal to 1 over a to the power of n. A negative exponent in the numerator is the same as a positive exponent in the denominator. And the last rule is the root rule. To find the root of a power, divide the exponents. Remember, negative exponents are not angry. They just want to be in the denominator. Alright. Time for a quick exponent showdown. Let's simplify 2 to the power of 3 times 2 to the power of negative 5. Now before your brain taps out, remember our golden rule, the product rule. When multiplying powers with the same base, we add the exponents. So this becomes 2 to the power of 3 plus negative 5, which is 2 to the power of 3 minus 5. And 3 minus 5 is negative 2. Now don't panic. A negative exponent doesn't mean it's wrong or sad or needs therapy. It just wants to be flipped over. So using the negative exponent rule, 2 to the power of negative 2 becomes 1 over 2 to the power of 2. When we simplify it further, it becomes 1 over 4. And that's it, we have figured it out. Example 2. Simplify x to the power of 4 cubed over x squared. On the numerator, we need to use the power to exponent rule. It is like giving coffee to someone who's already had an energy drink. It's math going full turbo. 4 times 3 is 12, so the numerator will be x to the power of 12. It is not simplified fully yet. So now we use the quotient rule. It is basically sibling rivalry. When exponents share a base, they fight it out by subtracting. 12 minus 2 is 10. So the answer is x to the power of 10. Next up is example 3. Simplify the cubed root of x to the power of 9 plus y to the power of 0. Here we use the root rule and the zero exponent rule. Root rule is like finding a hidden treasure, and the zero exponent rule is like your mum saying you'll always be her number 1, even if you bring home 0 homework. So this becomes x to the power of 9 over 3 plus 1. 9 over 3 is 3, so it is x to the power of 3 plus 1. And that is the answer in the simplest form. Let's take it up a notch. Example 4. 27 to the power of 3 minus 2x times 9 to the power of x minus 1 over 81 to the power of 2 minus x. So firstly, we can change these bases to get common base. We can use 3 as a common base. 27 can be 3 to the power of 3, 9 can be 3 cubed, and 81 can be 3 to the power of 4. It becomes 3 cubed to the power of 3 minus 2x times 3 squared to the power of x minus 1 over 3 to the power of 4 to the power of 2 minus x. We need to simplify the exponents by multiplying them, using the power to exponent rule. It becomes 3 to the power of 9 minus 6x times 3 to the power of 2x minus 2 over 3 to the power of 8 minus 4x. Let's put it in a way that will be easy to add and subtract the exponent-like terms. 3 to the power of 9 times 3 to the power of negative 6x times 3 to the power of 2x times 3 to the power of negative 2 over 3 to the power of 8 times 3 to the power of negative 4x. I will do the numerator first. 9 minus 2 is 7, and negative 6x plus 2x is negative 4x. The denominator stays the same because there's no exponent-like terms. The 3 to the power of negative 4x cancels each other out. Using the quotient rule, 7 to 8 is negative 1, which gives us 3 to the power of negative 1. This is a negative exponent. The answer must always have a positive exponent. Using the negative exponent rule, 3 to the power of negative 1 becomes 1 over 3. And that, my friends, is how you conquer exponents. We didn't just solve it, we raised the bar, and then powered through it. See what I did there? Power, exponents. Next up, surds. A surd is basically an irrational root, like the square root of 2, or the square root of 5. You can't simplify them into neat decimals, but you can work with them. The 3 key surd rules we will do on this video are simplifying, adding or subtraction, and multiplying. Let's start with an example of simplifying. We need to get the square root of 18. 18 is basically the same as saying 9 times 2. The square root of 9 is 3, but the square root of 2 is an irrational root. So the answer is 3 square root 2. Adding or subtracting work in a similar way. Only like surds can be combined. This example here has the square root of 3 as a like surd. 2 root 3 plus 5 root 3 is 7 root 3. When it comes to multiplying roots, you can multiply the numbers in the roots, as long as both are square roots. The square root of 2 multiplied by the square root of 3 is equal to the square root of 6. Working with surds is kind of like shopping. Only similar terms go together, and irrational ones refuse to round off. So whether it's rules of exponents or taming wild surds, now you've got the basics covered. If this video helped, give it a thumbs up, subscribe for more maths magic, and drop a comment if there's a question you want broken down. You got this.